Hey guys, this is the newest addition to the Gran family. This is Estelle Elizabeth Gran, born today, February 13th. So that's why I was gone today. Imagine that. All right, so here is my setup, just to give you guys a little insight into what I'm working with here. I'm at the hospital, and I've got a bathroom that's all my own that I can make videos for you guys in. So here we go. I've got my little setup here and my answer key to our review assignment for the quiz on Wednesday. Now, let's see if I can get it to focus just a little bit better. There we go. Now here's the deal. I already figured out that I made a mistake on my key with this very first problem. So what I want to do is just look through some of these problems and just highlight some stuff and just kind of talk through a couple of examples. So first off, the first section is just determining whether it's permutation, combination, or fundamental counting principle. How many 4-card hands can be created from a 52-card deck? Doesn't really matter what order I receive the cards in, because I can shuffle them around in my hand and it still makes the same hand, so that's a combination. I accidentally put permutation on the key. How many different orders can a 15 billiard or pool balls be hit into the pockets? This is permutation, so all of them are being used, but it definitely matters which order that they're going into, so that's a good one to know. And then fundamental counting principle, we've got our pizza parlor problem: 3 crust choices, 2 cheese choices, 15 toppings, and so that would be fundamental counting principle. Now, a couple of these, how you would actually do them. How many ways can Joseph, Michael, all these people stand in a line? So there's this is a permutation problem because it matters when it says how many different ways they could stand in line. So if I'm first, or if Joseph is first versus Michael first, those are 2 different orders. So we're going to do 6 NPR 6 in the calculator. You could also do 6 factorial, and it'll give you 720. Let's see, is that everything from page 1? That's all the ones I wanted to cover from page 1. Continuing in that same section though, how many moped license plates can you make if it's 2 letters followed by 4 numbers? So how many different plates can you make? And I changed the wording around on that one, I think, on the a little bit, because it made it seem like it was that letters couldn't duplicate, but that's not what it intended. It just meant unique license plates. And that's a fundamental counting principle. You've got 26 letters times 26 more letters times 10 times 10 times 10 times 10 numbers, possibilities, and that's your answer for that one. Let's see, 5 people are in a club, 3 are going to be in the planning committee. How many ways can the committee be created? That's a combination, doesn't matter what order they come in. And so in your calculator, you do 5 NCR 3 and come up with 10 combinations. Let's see. Some dice probability, so rolling 1 die, rolling any particular number, it's 1 through 6, so that'd be 1 out of 6. 3 even numbers out of 6, so it's 1/2. Make sure that you're going to reduce your fractions here. So if you got an answer that was different than what I have, maybe throw it in the calculator and see if it pops out the same decimal number as the one I did. Hopefully 1/2 wasn't the one that you had an issue with. But so anyway, 3 odd numbers, so 3 out of 6, that's 1/2. Number less than 3, so that's only 2 and 1, so that's 2 out of 6, which would reduce to 1/3. Number greater than 3, now that's 4, 5, and 6, so that's 3 numbers out of 6, which reduces to 1/2. Number greater than 6, there's no numbers greater than 6 in the number cube, so that one's 0. And a number less than 6, that's 1, 2, 3, 4, 5, so 5 out of 6. Let's see. Now, 29 and 30 you might be a little afraid of, and these are actually going to be more like what we do in 11-3. We might have enough information to figure these out. Basically, you're looking for how many possible combinations with this one have a beginning number of a 3 and then ends in a 2 or a 0. And so of the 10,000 total possibilities, it's like 200 of them fit both of those criteria, and so it's 0.02 as a decimal, or 1 out of 50. But don't worry if you couldn't do that one. If there's anything like it, it won't be that big of numbers on the quiz. It'd be more like something like, it'd be like the dice combinations where you can literally count them out. And then same thing with the lottery one. Probability of all the numbers being even, let's see. So that's 10,000 possibilities, and I think it ends up being that, what, 600, well, it must be 625 because it's 0.0625, or 1/16. Now this is a good one to pay attention to, 31. What is the probability that a person's birthday does not fall during one of the summer months? Key word, does not fall, right? Pay attention to that when you're reading these problems. The wording really matters with this. Now there's 3 summer months, so that would be, if it's not in the summer months, there's 9 non-summer months, so 9 out of 12, that would reduce to 3/4. Some of our dice combinations, again, it's really figuring out how many possible ones there are, dividing by 36, and then reducing the fractions. So a sum of 4, there's 3 possible sums of 4, so that would reduce, 3 out of 36 reduces to 1/12. Sum of an 8 or a 12, there are 6 possibilities there, so that would reduce to, 6 out of 36 reduces to 1/6. Sum of less than 3 greater than 5, there are 27 possibilities there, so 27 out of 36 reduces to 3/4. Less than 7 or greater than 7, there's 30. 30 out of 36 reduces to 5/6. And even sum, well, that one you can almost do without like counting it up, because half of them are going to be even, half of them will be odd. Some greater than 12, there's none. Some less than 12, there's only one way to make a 12, so the complement to that would be 35 ways out of 36 to make something less than 12. And last page. I think I'm going to keep this under 10 minutes. Okay. We'll start up here. So some theoretical, or experimental probability, excuse me. We've got our table over here that shows trials where we flip 2 coins. We either got heads and heads, heads, tails, tails, heads, so one of each, or tails, tails into these categories. So our first thing is the probability that both coins land on heads. Well, that's 14 out of the 60, which would be reduced to 7 out of 30. So the total number of trials here, if I add all these together, there was 60 trials. The coins match, well, that would be if it was heads, heads, or tails, tails. So I add those together, it's 29 out of 60, doesn't reduce. And then the coins don't match, that's our heads, tails, tails, heads, so 31 out of 60, again, doesn't reduce. Shaded region stuff. Alright, now remember, any geometry formulas that you'll need will be given to you, and if the sub forgets, tell them to read the sub notes. It says, you know, write the formulas on the board for you guys. So here we're looking for what is the area of this shaded section, so I need to figure out the area of the circle, the area of the square, subtract them, and then find the probability. So that's what I did. Here's the area of the square, the circle, subtract them to get this, so that's the area of our shaded region. So area of the shaded region over area of the whole target, which would be the whole shape is a circle, and this is our probability, 0.376, or 37.6%. With this one, a couple ways you could do this. You could potentially figure out what is the large triangle, the area of that. You could figure out what is the area of this triangle that's made up of the top white section and the lower, the middle blue section only. So it's that one. And then figure out what's the area of the little triangle on top. And if you subtract this like middle triangle that has a height of 8.75 and a base of 7, and then subtract the smaller triangle from it, you'll get this trapezoid here. Now I use the trapezoid formula, which is the height times the sum of the bases divided by 2 to figure out what this is. And then I divided it by the area of the entire thing to get that the area in blue is about 51.6% or 0.516. Then this one, this is a fun one. So we want the area of this kind of weird, I don't know what you would call that exactly, but it's like I have a cookie that's got a couple of bites out of it. So I figured out what is the area of the big overall semicircle, which was this. Then what's the area of this to subtract, and that's that one. Then what's the area of this little semicircle, which is this. And then I basically took the big one and subtracted the little two, and then got this as the area of the shaded section. So then 6.29 divided by the area of the whole thing, the whole semicircle, and I got 0.445. Alright, if there's any other questions, feel free to email them to me, and I'll do my best to check, to keep up on my emails and send them back to you guys, but you've got the rest of the day tomorrow, I guess, Wednesday, or Tuesday, to kind of get this stuff figured out. And good luck on the quiz on Wednesday. Be good for the subs.